Welcome to this explainer. Okay, today we are putting on our detective hats. We're going to embark on a little investigation, hunting down those elusive, deeply hidden application bottlenecks using Sentry's performance features. If you've ever had users complain that your app is just running slow, but you have absolutely no idea where to start looking, well, you are in the exact right place.
Okay, let's dive into this. Here's our game plan. First, errors versus performance. Second, the Performance tab. Third, decoding the waterfall view. Fourth, identifying the bottleneck. And finally, a real-world case study on a slow checkout.
All right, part one, errors versus performance, the forensic approach.
So let's get into the right investigative mindset here. When an application misbehaves, the stakes are super high. Users get frustrated and they just leave. But how we actually investigate depends entirely on the nature of the crime. Think of it this way. Error tracking is kind of like arriving at a crime scene and finding the body. The application crashed, an exception was thrown, like a divide by zero error. It's binary, right? It either works or it doesn't. Sentry captures that stack trace and tells you exactly what line of code broke. But performance monitoring? That's an entirely different beast. That is way more like profiling a suspiciously slow suspect. The app hasn't crashed. There are no big red error logs screaming at you. The application is just crawling. Without proper performance monitoring, debugging these slowdowns feels a lot like playing detective in the dark. We need specific tools to measure latency, throughput, and the exact duration of every single operation. Moving on to Section 2, the Performance tab, setting up the crime lab.
This is exactly where we transition from guessing to actually knowing. To start the hunt, we open up Sentry and head straight over to the Performance tab on the left side navigation. You're immediately greeted with a searchable list of transactions. Now, a transaction basically represents a single user request happening in your app, like loading a page or hitting an API. Now, step 3, and this is absolutely crucial, we sort our transaction list by P95 duration. Why not just use the average duration? Well, because averages lie. The P95, or 95th percentile, tells us the real experience of our top 5% most impacted users. If your P95 is high, it means a huge chunk of your users are experiencing severe pain, even if the overall average looks totally fine.
And boom! Right there on the dashboard, we spot a glaring clue. A P95 of 4.5 seconds for a really critical transaction. In the web world, 4.5 seconds is literally an eternity. Your users are just going to abandon the page. This is the exact tip-off we need. We've got our primary suspect, and it's time to dig deeper.
Section 3, decoding the waterfall view. Let's piece together these clues. We are now shifting our focus from that macro-level dashboard straight down to the micro-level behavior of one single slow transaction. To really read a waterfall view, we have to understand its fundamental building block, the span. A span is a named, timed operation representing a single piece of the application workflow. If a transaction is an entire pizza delivery, a span is the time it took to actually bake the pizza, or the time it took to drive it to the house. In Sentry, every database query, every external API call, every template rendering, they all become distinct spans with their own precise execution times.
And this brilliantly illustrates how those spans actually stack up visually. When we click right into our slow transaction, Sentry generates a waterfall chart. It organizes the spans chronologically and hierarchically. You can literally trace the exact path of the request. Notice how the overarching HTTP request took 3.0 seconds, but beneath it, we can see exactly where that time vanished. Half a second on an auth API call and a whopping 2.5 seconds on a database query. So we no longer have to guess why the HTTP request was slow. The visual evidence points straight to the database.
Section 4, identifying the bottleneck, zooming in on the culprit. Okay, we've seen the waterfall, but now we really need to zoom in on the exact culprit to convict our suspect code. This is the investigative process in full swing. We're moving right past that high-level transaction, bypassing the front-end UI spans, skipping the HTTP network calls, and digging straight down into the specific database operation. Sentry's distributed tracing automatically connects all these dots for us, jumping from the front end completely down to the back-end infrastructure without breaking a sweat.
So the crucial question is, what do we actually find when we click on that slow database span? Sentry opens up a panel of what we call span evidence. First, it gives us the precise duration. Next, it gives us the duration impact, meaning how much of the total transaction time was completely hijacked by this single span. And finally, and honestly most powerfully, it gives us the exact query syntax. It highlights the exact SQL query being executed right there for you to see. You don't have to go digging through disparate back-end server logs. The smoking gun is handed right to you.
Let's bring this to life. Section 5, Case Study, Slow Checkout, Solving the Mystery. It's time to put our methodology to the test on a high-stakes IT support ticket. Imagine you are the IT investigator on a Monday morning. Support tickets are just pouring in. Users are trying to buy items, but the checkout process is absolutely crawling. They're clicking pay, the loading spinner is just spinning endlessly, and carts are getting abandoned left and right. The business is actively losing money. Why is this happening?
You spring into action. And as a quick aside, Sentry's core performance monitoring is remarkably accessible. You can actually do this kind of debugging using Sentry's free developer tier, which captures up to 10,000 performance transactions a month. Anyway, you open up Sentry, go straight to the Performance tab, and filter for the specific transaction causing all this pain, post/checkout. You sort by the slowest P95 durations, find an egregious outlier, and click right into its trace view to see the span waterfall.
Now, what's really interesting about this massive anomaly is what jumps out at you in the waterfall view. A single span taking 2.3 seconds. In the context of a payment processing checkout, a 2.3-second delay on a single internal operation is just lethal. You click on this highly suspicious span to inspect the evidence.
And there is our culprit. The span details reveal it isn't a third-party payment gateway failing, and it isn't a slow front-end React render. The exact syntax reveals a 2.3-second select database query that is fetching a massive dataset without proper indexing. The database is totally choking on the request, and the entire checkout process is held hostage waiting for it to finish. Mystery solved.
But hey, an investigation isn't complete until the fix is actually in motion, right? Here is the incredibly satisfying resolution. Step 1. We've identified the bottleneck query. Step 2. We go up to the top of the Sentry page and copy the exact trace ID for this transaction. Step 3. We paste that trace ID directly into a Jira escalation ticket for the engineering team. Because Sentry unifies errors, traces, and performance with all the code context, the engineers don't even have to try to reproduce the issue locally. They just click the trace ID, see that exact 2.3-second query, and know exactly which database index to create to fix it for good. Which brings us to the end of our investigation. Sentry really transforms performance monitoring from a stressful guessing game into an exact science. By utilizing the Performance tab, decoding the waterfall view, and analyzing span evidence, you can directly connect user frustration to a specific line of code or a rogue database query. So, I'm going to leave you with this question to consider. What performance bottlenecks are silently hiding in your application's code right now, frustrating your users without ever throwing a single error? Armed with this methodology, you're absolutely ready to go find out. Thanks for joining me on this explainer, and happy hunting.